Hi there. In this video I'm going to show you how to design your own AMP chassis in Fusion 360. Fusion 360 is a CAD software that you can get a license for free for personal or hobbyist use, and it has many features. One of them is creating sheet metal objects, and it helps us on designing our own custom chassis. Okay, this design here is an example, is a 5F2 Fender chassis, but I'm going to show you how to draw a 5F1 that is smaller and simpler. So let's get started. This is the screen you see when you first open Fusion 360. So to draw a chassis, you have to go to the sheet metal tab, and the first thing you have to do is creating a sketch. So just click here and click on this surface, that is the XY plane. Okay, and now you can start drawing, but we need to have some dimensions as a guideline. So I searched on the Amplified Parts website, and they have some dimensions here. If you look for Fender style 5F1 chassis, you can find this guy here, and you go to the Files tab and you can click on this PDF where you have your dimensions. So the drawing or the design will start with the top part of the chassis. That is this rectangle here, that is 105 millimeters by 222 millimeters. Sorry guys, I am a metric guy, so if you are a inch guy, you have to get your measurements correctly. Okay, but it won't be a problem in Fusion 360. Okay, so going back to Fusion 360, I'm going to use this tool here, that is rectangle. Okay, if you click here, you have many options of tools, but for being short, just click in on rectangle, click on the origin, and just click again to make a rectangle. Okay, now I got to enter with the dimensions, so I have to press the letter D on the keyboard. So the tool of dimension is active. You can see on the icon close to the pointer, and you just have to click on the line. You're going to define the dimensions, click again, and you just enter the dimension and press enter on the keyboard. Okay, I'm going to do that again here. So click again, put the dimensions, press enter. Okay, when that is done, we have our first sketch. Okay, so I'm going to click here on finish sketch, and for putting the drawing on a 3D perspective, I'm going to click here at the right top corner on this little icon here. So that's it. Okay, some functions for the Fusion 360 for those of you who are not used to use CAD softwares are: the scroll of the mouse can do a function of zooming. So if you point the mouse anywhere in the design, and scroll. You are zooming in and out. Okay. Other tool that is helpful is the pen tool. You just click on the scroll, this little hand will appear, and you can movement the design. Okay. Other helpful tool will be the orbit. You just press shift, click on the scroll, and you can orbit the drawing. Okay, that's it. Next step doing the chassis is creating our first flange. Okay, just click here in this tool called flange, and you click here, and it will create our first sheet. Okay, so click OK. Now we are going to modify the thickness and the rules for bending, which is an important step for fabricating the chassis. Okay, so we have to go here in sheet metal rules in this icon. Okay, it has already selected a rule from the library, but we are going to use a specific rule created for the material we are using here, which will be stainless steel. Okay, so you click here in new rule. You can modify the name of this rule. I am going to put it as a stainless steel, and I'm going to put here the thickness, which will be 1.2 millimeter. Okay, so we have to define the thickness here, which will be 1.2 millimeters. Okay, and there is this K factor, which is used for bending the flanges on the chassis. Okay, for each material and each thickness of sheet, you have to use a different K factor. But there are many tables on the internet that you can use. The easier spot to get those tables are in the website of the SandCutSand company. There are many tables for many materials and thicknesses. Okay, so I have here saved in my computer one of those tables, and I will get an example from here. Okay, the 0.048 sheet metal is equivalent to a 1.2 millimeter, so the K factor for that is 0.36. Now I'm going back to Fusion 360 and update here to 0.36 and just save. Okay, so I'm going to close here, and now I'm going to go here in the design and just click here in switch rule, and I'm going to find the stainless steel 1.2 millimeter. Okay, just select here and click OK, and you see that our sheet has updated. Okay, so next step is making the flanges. So the first flanges we're going to do are those front and back flanges, and we have to go back to our drawing and get the dimensions from there. So it is 67 millimeters. Okay, so going back to Fusion, we just go here in flange, we just click on the lines here. Okay, just be sure that you are selecting the upper line, not the lower one. Okay, and you just grab this arrow here to define a direction, and then you go here and update the measurement. Okay, well, it is done. um, Now we are going to draw the other two. Okay, so create flange, click there, click here, go up, but I'm going to make it a bit shorter. Okay, we can adjust that later as needed. Okay, I'm going to put here 65 millimeter. Okay, and now we are going to make the tabs. So selecting the internal line and just put here. You are going to put the dimensions as the drawing, but there are some limitations here. Some companies ask for minimal folding tab, which can be hard to achieve using the dimensions from here. For example, the company which makes my chassis requires at least 12 millimeters. Okay, so just for an example, I will follow the dimensions on the project here. Okay, so 9.5 millimeters. When the dimension doesn't appear here, you can just push the arrow again and it will appear, or you can go here and update. Okay, so 9.5. Okay, that's it. You have the base of your chassis. Okay, so well, how I do the holes? Okay, you have to go back in the sketches and do the basic drawing of the features of this chassis. Okay, so you click here in sketches. You will have a list of sketches you are using. For now we only have one. I will click here in this little eye to show it. You can see that we have our primitive drawing, so I cannot be confused in the future. I will click here with the right button of the mouse and clicking rename. I will type top, which is the top part of the chassis, and just press enter. Okay, so to modify that sketch, I will click here with the right button and click and edit sketch. Okay, so going back to our drawing, we have those dimensions here. Okay, so I'm going to draw another rectangle of 47 millimeters by 57. Okay, so just click here in rectangle, click again, and now press the letter D to get access to the tool of dimension. Click on the line, click again, and just put the dimension. Okay, same thing here. Okay, the drawing won't show it here, it is implicit, but this rectangle is centered at the chassis, so we're going to do that in Fusion 360. Okay, so going back to Fusion, we have 57 millimeters, and the overall motorcycles. So we have 105 millimeters overall. Let me get 105 minus 57 millimeters divided by 2. Okay, so 24 millimeters. And I'm going to get the dimensions from this corner for the origin, which is one of our references, and just put it here. Okay, 24. So it is centered. If you check here, it will give us a message that the dimensions is over constrained. Okay, so just click on cancel. That's okay. It is centered, and there is not a measurement that defines this line from here, but we can get close enough just eyeballing. If we have 14 millimeters for this hole, we are going to put something like 16 millimeters. Okay, so just click on this line for the origin and put 16 millimeters. Okay, we can now do the holes. Okay, don't be afraid with the corners, we can adjust that later. Okay, will show you how to do that. So just make some circles here. I just clicked here on the circle tool. Okay, and now we are going to align those circles with some references. We have in Fusion 360 something like something called constraints. Okay, we are going to use here the horizontal and vertical constraints, so we can align those centers of those circles. So just click here, click in the center, and click on the other center, and they will be aligned horizontally. Okay, so I'm going to click again here and here, and they will be aligned. Same thing here, here again, and that's it. They will be aligned. Okay, let's go back. So there is a distance of 64 millimeters here from this circle to this one. So let's just do that. Click D for dimension, or press D for dimension, and just put here it is 64. Yes, and the distance from here to here, it will be 20 as the drawing. Okay, the distance from this center to this center will be 51. So just going to do that, and we have to make sure that the center of this line to here is the same distance from here. So well, it will be easier just drawing 14. So no, it won't be good because we don't have the right distance from here. So well, let's just divide 51 by 2. That will be 25.5 millimeter, and I'm going to create a point here. Just click here and create, click in point and put it at the mid of the line. A little triangle will show here, and you click here. So just click here and here and 25 point half. Okay, it is centered, and the whole dimension will be 6.5. So click here, 6.5, and you don't need to do that in all the holes. You just come here in constraints, click equal, click here, and they will have the same dimensions, and just repeat for the other holes. Okay, click here, and only for demonstration I will finish sketch. I'm going to click here at the home view, and I'm going to do this, just seeing the chassis with other view. And now we're going to cut the chassis. Okay, so I will click here in extrude. I'm going to click here and select all the features. I will grab the arrow, and I have to define a distance. You can just put 1.2 millimeter, that is the thickness of this sheet. Okay, so it is almost ready, but we have to put some fillet here, some rounding. So I will just click here in fillet, click on the lines. You can orbit the drawing, and do that on the 4 sides at the same time. Okay, you can do that directly on the sketch, but sometimes it breaks all the stuff. I will put here a radius of 3 millimeter. Okay, so let's go back. Well, you will have to make all the holes in your chassis, and just for an example, I'm going to make a hole here. Okay, you will have to make some tedious process of getting all the dimensions and putting here and doing everything we did previously. So just so you can go on, let's create a hole here in the front panel, for example. So I will create a new sketch, and the tool for sketch asks you to select a plane or planar face, and we will select the face we are going to draw. So here, okay. Well, if you need some reference, you have to create it in Fusion 360. The origin is a good point for a reference point, but sometimes you want to use those corners as references, and you can do it just clicking. You have to create a projection, so you have to press the letter P, okay, and you select where you need to put a projection point that will serve as a reference here. Why? Because when you create a sketch in a plane, you can see that this point here is not in the same plane, so you have to make this reference point. Okay, so just press P, select the reference, and click OK. So let's do it again. I will only make a simple hole here, let's say a 10 millimeter hole, which is referenced about 30 millimeters from origin, and about 120 millimeters. Okay, finish the sketch. Okay, we need to go here in extrude, click the hole, move to the direction we want to cut, and you have to make sure the operation here is cut. Okay, there are many options here, but just click here, select cut, and the dimension will be minus 1.2. okay, if you put positive, it will make a different operation. It will create some extrusion here. Okay, so just for example, that's it. Other stuff you can do is I put this tab lower than this tab for obvious reasons, so it cannot interfere with that when bending the size. But we can click here, let's cancel here, and if you click here in the history of operations, you can see what are the operation, which is the operation that made this flange here. So we can click here and click in edit edge flange. Okay, and you can adjust the distance to what you need. Okay, so let's say I want to make the distance from this surface to the lower surface of this flange here 1 millimeter. How do I do that? I must check. Okay, so I will click here in inspect. I will click here at this surface. I will orbit this and click here, and will give us a difference, the distance here. So the distance is 0.8 millimeter. So it is not correct for what we desire. So I'm going to go back here in the flange, edit flange. Okay, so I will subtract 0.2 millimeters here, so 64.8. okay, then I'm going to inspect it again, and it's 1 millimeter. Okay, other stuff you can do, it's breaking the edges, breaking the edges here. So just click in fillet and go to every edge and do accordingly with what you want. Okay, so I'm going to put here just 1 millimeter. Okay, and you can just use the tool here and do all the edges of the flanges. Okay, so I did this one, and I want to go and make that one. In order to not get a very extensive history line, I can just click here again and edit feature, and click here and create another edge and put the dimensions 1 millimeter. And before clicking OK, I can just click on the other two left just click OK here. Edit feature again, and let's click on the other one. And put a dimension here, 1 millimeter, and just press enter or click OK. So we have our primitive chassis here, right, with some features like the transformer mount, and it is ready for some fabrication companies. You can just save it as a Fusion file. Okay, how to do that? Just click here in File, and you just click here in Export, and you put a name on it and select the type with the F3D extension here and export, and you're ready to go. But sometimes there are some, well, there are some companies that ask for a flat pattern. How to do that? It is pretty easy to do on Fusion 360. You just have to click here, and you just have to select the stationary face. I will click here, and when it is selected, you just click OK, and here we go. We have it ready. So we have to export a DXF extension file which have all those drawings of the flat pattern for fabrication. That's what they use to send to the laser cut machine. Okay, so you just have to click here in this button. Okay, just click OK and save it. Okay, great. Once you're done, you can finish flat pattern, because there are some companies that asks us for some views of the project or the design. Okay, so how you do that? You just click here in this button and select drawing, and then from design. Okay, you can save it. Well, let me go back again. Drawing from design. Okay, just click save. Because I didn't save the project yet. Okay, well, you can select the sheet size. In this case is the size of the paper you're going to print it if needed. Okay, I'm just using A3 paper size here. Orientation landscape. Just click OK. It will take some time because my computer is slow, but it will create a drawing frame here, and you can bring the views here. So notice that when the drawing page opens, you already have some view presented here, and you got the scale of this view here. So I'm going to change it to a better size and point scale of half the size will be okay here. So just adjust it there, and I'm going to put the base view here. Okay, you can just click OK here in this tab. The base view is here. You can see that we have the front view and we have the hole here with the center point, and you can draw the projected view. Just clicking on this button, you can click here and you just drag to where you're going to get your view. Okay, so those three views here are sufficient, but sometimes it is good to make an auxiliary or a projected view from a different angle, so they can see where the tabs are folded. Okay, because sometimes if they fold the tabs in the wrong direction, you cannot use the chassis as you want. Okay, so that's it. But just for improving the view here, I will click in this view and click in edit view, and well, come on, go. Well, okay, and I will click here to a shaded view, so you can see it better. Okay, well, now it is almost ready. You just have to click here in dimension, click, push, click, push, and add the dimensions as needed. Okay, I'm going to make just a few here, just so you can see an example. Okay, you can do many views, many sheets here, but it's rarely needed. Okay, so when it's done, this version of Fusion 360 for personal usage doesn't allow you to export a PDF of this. So how you can do that? You just click Ctrl P to print, and just select the Microsoft Print to PDF and save it, and do as many of views you need to satisfy your fabrication company. And that's it. That's the whole process on how to draw your custom chassis. Okay, it will take some time. You will have to have all the measurements needed, as transformer, mounting screw dimensions, and socket dimensions. Well, I just showed you the basic process, and that's it. Okay, so I hope this simple tutorial can help you to make your own chassis. Okay, so I'm just asking you for subscribe to the channel and liking the video. It will help me to know if the content is good, and if I can keep helping with some ideas. Okay, so thanks, see you later, bye.